Hey there, and this is our second video on doing monohybrid crosses. In the first one we crossed two homozygous individuals, one for brown eyes and one for blue eyes, and we got 100% children with brown eyes, but they were heterozygous. Now our second cross is we take two individuals who are heterozygous for the condition of brown eyes, and we cross those, and we'll see what happens. So we've got a question: cross two heterozygous brown-eyed individuals, predict the probabilities. And I'm going to try and be a little bit more fancy and use some color in this video on my pen, so let's see how this goes. So first task, write down each of the labels. So what are the parents? So we've got a parental phenotype, and let's switch across to a bit of brown. We've got brown-eyed mother, let's call her mother, and the father is also brown eyes. So, parental phenotype, what's next? We need the parental genotype. Parental genotype. And we've got mother is big B and father has big B, and mother has little b and father has a little b. Okay, so big B little b for mother, big B little b for father. Now we need to identify the gamete genotype. Now in the previous video I had little circles drawn, but I'm going to just do them and sketch them out here. So one egg, one sperm, and one sperm. Now if you're doing this with plants, obviously you don't have eggs and sperm. So this big B goes there, and little b into this one. You don't need to draw these lines, I'm just showing where I'm putting them. Big B and a little b. And just to be clear, those aren't necessary, so I'm going to rub them out. Okay. So we have one gamete with big B, one gamete with little b, one sperm gamete with big B, one sperm gamete with little b. Okay, so now we do our genetic diagram and we use our Punnett square. Punnett square. The scientist, Punnett, was a geneticist, but apparently he didn't actually use the Punnett square, so interesting. Tic-tac-toe box, or knots and crosses. We'll sketch that out like that, and let's put mother down the side. We'll put father across the top, and father has big B, mother has big B. Father little b and mother little b. So let's cross them over. Big B, big B, big B, little b, and I'm going to do this in order. Change my pen. So big B, little b, and then we have big B and little b. Remember, we put the dominant first, and finally little b, little b. So now we identify what would be called the F2, since the homozygous cross was F1, but let's identify the offspring genotype, and we label it offspring genotype. And we have big B, big B, big B and little b, big B and little b. Pen switching here. You don't need to change colors in your exam. And little b, little b. Now we need to identify the offspring phenotype. Offspring phenotype. So we identify the features of the offspring. So this one homozygous dominant for brown eyes. I could have used my colors there. You know what? I'm going to stick with using my colors. Homozygous dominant for brown. Heterozygous dominant for brown. Another heterozygous dominant brown. And we have a homozygous recessive for blue. Now we identify our offspring ratios. Offspring ratio, and we have 1, 2, 3 brown to 1 blue. Or, if you're asked for a percentage, it's going to be 75% brown to 25% blue. And this 3-to-1 ratio is where Mendel got his numbers from, and it's to do with the phenotypes that he saw, because he didn't know then that there was a recessive, 2 recessives in there in the heterozygous. All he was looking at was the color of his flowers, and we've got the 3 browns and the 1 blue. Now this number you get a mark for, and you'll get a mark for each section here, so that's why it's worth writing the whole thing out so you don't make mistakes. Okay, and that took me 6.5 minutes to write it all out, changing my pen. You will have 5 minutes per mark in your exam, so you've got to do it pretty fast. All right, over to you. Practice.